Uh, no. Hey Mikey, welcome to the first of hopefully what will be many maths videos. So I've actually done 3 of these. It just doesn't seem to work out. So hopefully this is recording and that you're able to learn and that I'm able to learn. But today, cutting to the chase, we're speaking about circles. I've tried to get this configuration so that you can read quite clearly. I'm not in the way of the board, and also at the same time, we can look at this as an interactive session. So the idea I've had is I know Euclidean geometry was sent to me, so we're going to focus on circles. And I thought instead of just solving the problems as they are, there could be well, I'll go through a couple of things that I thought were quite fundamental when I was in grade 11 that I needed to understand. They help, they kind of, because maths plays, it's building block by building block by building block, these I felt were quite important theorems. And I'm going to do 1 or 2 quick videos on that. I'll upload them independently, and then I'll jump into your problems. I'll solve one of them, and I'll leave the other one, having looked at that, I'll leave the other ones, or the other one for you. And then later on, I'll post a solution to it. But I'm sure you'll figure it out. It's been so long, you probably have already figured them out. But I have a good system working now, so if you keep on giving me questions, I can keep on doing answers for you. This is a holiday, so we'll see how it goes. But the first thing, circles. They are friends. They are nice. Um, they're nice shapes. They've got great properties, and they make the world go round. No pun intended. So, just going over some things that always slip my mind, but are quite important as well. Often, a circle, it has a center, the circumference around it, and often what we're going to be looking at, because this is Euclidean geometry, we're going to be looking at triangles and shapes within a circle. And one of the most fundamental things to always remember is just the relationship of the radius, because the radius from the center to the circumference is always going to be the same dimension. Whenever we make a triangle from the center outwards, we are always going to get the property that the sides of the triangle, the two sides of the triangle, I don't know if you can see this, but they're always equal. And so we always end up with isosceles triangles. That means that if we have the 3 angles, we know that both of these angles are identical and B will be a different one. Unless it's an equilateral triangle, then we know that 2A's plus B always satisfy the criterion of a triangle that they're equal to 180 degrees. Okay. That's one fundamental thing, and we're going to be seeing this a lot, and especially in the theorems I go through. We're always going to see that we have the angles adding up to 180 degrees, and we use the fact that these are isosceles triangles a lot. So that brings me on to the next point that we look at, and that's the property, or this word that I always used to hear and it frustrated me, but subtended angles. Why, oh why, could they not choose an easier word? So, what is a subtended angle? Because it sounds like a strange creature. So let's start off with, as always, in geometry, a point. So I have a point, and what I'm going to do is I'm going to relate this point to this. Subtended angles can come from a number of things. Because we're dealing with in circles, we can have an arc. Perhaps we have arc over here. I hope the green comes up. If it doesn't, you can just believe me. We can have a line segment, perhaps. Okay, or any shape. Now, subtended angles occur from this point. Well, initially, if I have a given point, I can draw rays from it. A ray is just a straight line going a direction. And we get a subtended angle if from the point I can draw 2 rays that meet the end points of either an arc, a line, a tangent, okay? And if it actually touches the end points of these, I can then say that the angle formed between the 2 rays I've drawn, I can say the angle I've drawn, that angle, let me call it A in this instant, I can say that angle A is either subtended by the arc, or I can say it's subtended by the line, but basically the 2 rays that help form the angle must touch the end points of some member. And so that's something that we'll hear a lot, but these form subtended angles. And that brings us to the end of our first video. Woo!